Hi, everyone. In today's lesson, we will be taking a look at Chapter 3.5, Solve Equations Using Integers, and also the division property of equality. Now, this chapter, as always, comes from the OpenStax Pre-Algebra textbook, which you can find online for free. Now, the learning objectives then for the lesson are to, 1, determine whether an integer is a solution to an equation. 2, solve equations with integers using the addition and subtraction properties of equality. 3, model the division property of equality. 4, solve equations using the division property of equality. And then finally, translating words to an equation and then solving that particular equation. So let's go ahead and get started on that first learning objective. All right, let's look at this initial learning objective, which is to determine whether a number is a solution of an equation. So what we're going to do is we're going to take each question here and we will substitute each of the variables into the equation. So this is the skill we're learning with this particular objective. Now, we will also learn how to solve equations, but in this case, we are simply substituting a number into the variable and confirming whether that satisfies that equation. So starting with question number 1, then we have 5x plus 3 equals 18. And this first one, we're going to try and see, does x equal -3? Does that satisfy this equation? So what we're going to do is we're going to take the x variable out, and I'm going to put a -3 into its place. So x variable leaves. Now I have 5 times a -3 plus 3 equals 18. Okay, so now we're going to determine whether the left-hand side of the equation is equal to the right-hand side of the equation here. So my first step then here is to multiply 5 times -3. 5 times -3 is -15 plus 3 equals 18. Now, -15 plus 3 becomes, well, think about it this way. You have -$15. If we're thinking about it in terms of money, we have -$15. We're adding $3 to our bank account. So this actually, if I draw my number line here, I start at a -15 and I go back to the right on the number line 3 units. And where I end up is at a -12. So I have a -12, which is equal to 18. So now I ask myself, is -12 actually equal to 18? And it's not. -12 does not equal 18, which means that x cannot be -3 for this particular equation. Let's test the second variable now. So we have 5x plus 3 equals 18. And I'm going to test whether x equals 2 satisfies this equation. So inputting 2 into the variable, I now have 5 times 2 plus 3 equals 18. 5 times 2 is 10 plus 3 equals 18, and 10 plus 3 is equal to 13. Now 13 obviously does not equal 18, so we will put a slash through our equal sign. Let's try the last of these now. So 5x plus 3 equals 18. Now I'm inputting x equals 3 into my equation. So substituting the 3 into the x variable, I now have 5 times 3 plus 3 equals 18. 5 times 3 is 15. And 15 plus 3 is indeed equal to 18 here. So our answer choice for question number 1 is x is equal to 3. Now let's try question 2. So we have 7b plus 21 equals -35. And we're going to first test whether b equals 2 allows us to satisfy this equation. So we will substitute 2 into the b variable. Now I have 7 times 2 plus 21 equals negative 35. 7 times 2 is 14 plus 21. And 14 plus 21 gives me a positive 35. Well, I have a negative 35, so a positive 35 does not equal a negative 35. So we need to put a slash through our equal sign, and we now know b equals 2 cannot be a result. So trying out our second variable now, we have 7b plus 21 equals negative 35, and now we're testing whether b equals a negative 8 here. Okay, so we have 7 times negative 8 plus 21 equals negative 35. Okay, well, 7 times negative 8 then is equal to negative 56 plus 21 equals negative 35. So now we're starting on the negative side of our number line. So let's go ahead and draw a net number line. Starting at negative 56, and I'm going back 21 total units. So it's basically like I'm subtracting the two numbers because they are differently signed numbers. You're finding the difference between 56 and 21, even though you are adding it, you are going back towards the zeros. But if I subtracted the two, 56 minus 21 in a sense, 6 minus 1 is 5. 5 minus 2 is 3. That indeed does now match up to a negative 35. So negative 35 is equal to a negative 35. So our answer choice now is b equals negative 8. And since we've come across our answer choice, there's only going to be one correct one here. So b equals negative 8 is our result here. All right, so that's determining whether a number is a solution of an equation. Let's look at the next learning objective, which is to solve equations using the addition and subtraction properties of equality. And we're asked to solve for the unknown, which is the variable, for question number 1 here. So we have m plus 9 equals a positive 3 here. Okay, so now what we're going to do is we are going to do the opposite of adding 9, excuse me, and we're going to subtract 9 here, right? So we're doing the opposite of addition, which is subtraction, and we need to do that to both sides of our equation. And what we get here is m, 9 minus 9 is 0, so you could put a 0 there or you could leave it blank, equals 3 minus 9. So 3 minus 9, if I go to my number line here, if I start at positive 3 and I subtract a positive 9, I'm going to the left 9 units, and I'm going to end up at a negative 6 here. So 3 minus 9 is equal to negative 6. Now, if you use the previous skill we just learned, we're essentially using that skill to check our work, to make sure that we've come to the correct conclusion. So we can take our original equation here, m plus 9 equals 3, and input a negative 6 into the m variable. And then we ask, okay, does negative 6 plus 9 actually equal a positive 3? Well, negative 6 plus 9 is positive 3, so we can check both sides of our equation off, that we've come to the correct conclusion here. So question number 2, I have p minus 6 equals negative 11. Now in this case, the negative 6 is next to the p variable. That's what we need to eliminate, and we can do that by adding a 6 on the left-hand side of the equation and adding a 6 on the right-hand side of the equation. So now what I get, I can drop my p variable down. Negative 6 plus 6 is 0. I can drop down my equal sign, and now I have negative 11 plus 6. So if I go to my number line here, and I start at negative 11, and I'm going back 6 units, where I end up is at a negative 5 here. So we get negative 5 as our result. Question number 3 then is y plus a negative 4, which equals negative 15. Now this is interesting. There is a couple different methods or ways of thinking about this. You could decide to subtract both sides by the negative 4, that's the opposite, or we could basically change this to a single sign. So I'll show you both methods that you could do to solve this one, depending on which way you want to think about it. So for the first method, let's say we subtract both sides by that negative 4 here. So I subtract by negative 4 and I subtract by negative 4. Now remember, negative 15, I'm going to put this all in a horizontal row now. Negative 15, minus a negative 4. This is you starting with negative 15 and then you're subtracting a negative 4. Well, subtracting a negative 4 is the same as adding 4. So you could rewrite it like this. Negative 15 plus 4. If you go to your number line here then, you're starting at negative 15 and you're going to the right 4 units. And where I end up is at a negative 11. Okay, so y is equal to a negative 11 here. Now, you could subtract the negative 4 by both sides, or you can essentially do what I did down here in your initial step here. So if I see adding a negative, and I want to change to a single sign, I might realize that adding a negative is the same as subtracting a positive. So I could rewrite this as subtraction symbol and a positive 4 here equals a negative 15. And then I can add both sides with that positive 4 on the left and the positive 4 on the right. And what I end up getting is y, negative 4 plus 4 is 0, equal sign. Negative 15 plus 4 is your negative 11. So the model for this would be the same as the initial number line down there. Okay, so that is solving equations using the addition and subtraction properties of equality. Now let's look at a problem that asks us to model the division property of equality, in which we're writing an equation that's modeled by envelopes and counters, and then we can solve that particular equation. So essentially what this is doing is it's showing a balanced scale or equation essentially, where on the left side of the equal sign are these envelopes, and on the right side are counters which represent specific quantities. So the envelopes really are unknowns. So each envelope we could label with a different variable. I'll go ahead and label with an x. So there's basically 4 x's, right? Which if you added all those x's together would be equal to 4x. And then on the right side, we have our counters, which if I count them, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers in total. And what we're really trying to do is solve, okay, how many equal counters go in each of these envelopes? Okay, so now we have this equation, 4x equals 8, and we can solve this equation. Now, this equation is currently showing multiplication, 4 times x equals 8. The opposite operation of multiplication is, well, your division property, right? So we can divide by 4 on the left-hand side of the equation and by 4 on the right-hand side of the equation. And what we then end up getting is x is equal to 2. So in other words, 2 counters will go in the first, 2 counters will go in the second, 2 counters in the third, and 2 counters in the fourth for your 8 in total. So going from the model to actually solving equations using the division property of equality and then checking our solution, we're given a few different questions that we can go ahead and test. So the first question, question 1, is negative 6 is equal to 42. So we are asked in this case to solve for our x variable. Now currently the item in the way of that is that negative 6 next to x, which we can go ahead and divide away from the x, because negative 6 next to the letter means multiplication. So I can divide each side by negative 6 now. This then divides down to 1, so really this is 1x, negative 6 divided by 6, which is really just x, equals 42 divided by negative 6. 42 divided by 6 is 7. A positive by a negative is a negative 7. So the most simplified version of this is just the x variable by itself next to our negative 7. Now checking our work, we would take our original equation, negative 6x equals 42, and we will substitute the negative 7 into the x variable. So now it is negative 6 times negative 7 equals positive 42. So I now have a positive, or a negative by a negative, and a negative by a negative equals a positive. 6 times 7 is 42. So now we have 42 and 42, and I can check off my work that satisfies that particular equation. So that's question 1. Question 2 is negative 160 equals a negative 10y. This represents a multiplication relationship right now, negative 10 times y. So to move the negative 10 away from the y variable, to disconnect it, we need to divide negative 10 from the right side of the equation and negative 10 from the left side of the equation. So again, negative 10 divided by negative 10 is 1, or I kind of like to just put a slash through it really, kind of eliminates it. And then we have the y variable equals negative 160 divided by negative 10. Well, 160 divided by 10 is just equal to 16. A negative by a negative is a positive, so we would leave this as a positive 16. Now, checking my work, I would input the positive 16 into the y variable now. And we have a negative 10 by a positive 16. So 10 times 16 is 160. A negative by a positive is a negative. So we can check off our work that says, okay, negative 160 and negative 160 is in fact equal to each other. The last question is interesting because it includes a 0 here. So we have negative 5z equals a 0. Now we have that negative 5 next to the z variable. So to get the 5 away from the z, we do the opposite operation that relationship is currently showing. It's currently showing multiplication, negative 5 times z. The opposite of multiplication is division. So I'll divide negative 5 from the left-hand side and divide negative 5 by the right-hand side. Now negative 5 divided by negative 5 becomes 1, or we can just clear our terms. The z variable then drops down, equals. Now I have a 0 in the numerator divided by a negative 5 in the denominator. So if you have a 0 in the numerator, your answer becomes 0. So z is equal to 0. Now on the other hand, if I had the 0 in the denominator, so let's say instead I had 0z equals negative 5. Well, in this case, I would be dividing both sides by 0. And then I have a 0 in the denominator, okay? So anytime you have a 0 in the denominator, your answer is not 0. It's actually called undefined. Or if you put it in a calculator, it usually comes up with a sort of error message. Okay, so you can't have a 0 in the denominator. The next learning objective is to translate an equation and solve that equation. So we're going to take word statements and change it to an equation and then solve. So first off, we have the sum, which means addition, of 9 and x. Those are combined together. Is, which is an equal sign, negative 5. So I have 9 plus x equals -5. Now you could also write it, it usually is more formal to write the variable first with the 9 next equals -5 here. Okay, so now we can solve this equation by subtracting both sides by 9. So subtract 9 on the left side and subtract 9 on the right side of the equation. And we get x, 9 minus 9 is 0, equal sign. -5 minus 9 is -14. Okay, if I showed this on the number line here, again, -5 is here, and then when we subtract 9, that decreases our value. Subtract +9, we go back 9 units, and we end up at a -14 here. Okay, let's look at question 2. Question 2 reads, the number -77 is, that's an equal sign, the product, that means multiplication, of -7 and y. So I'm multiplying -7 and the y against each other. So if I write this in order, we'd have -77 is equal sign, the product of -7 and y. So now I have this multiplication relationship. To undo this, to get the y by itself, we would divide by -7 on the right side and -7 on the left side. And we would get -77 divided by -7. 77 divided by 7 is 11. Negative by a negative is positive. So I would have positive 11 equals, that basically changes to 1y. You could write it just as y though. So I have 11 equals y, or I could reorder the equation to y equals 11. Either way is a valid way of writing that answer. Question 3 then is interesting because of the word less than. So this says 8 less than z is -10. So less than is a subtraction symbol. However, less than reorders the number and the variable. So instead of writing it as 8 minus z, less than reorders it to z minus 8. Okay, so whenever you see that less than, know it reorders the numbers or the variables. And then we have is, which is equal sign, -10. To solve this question now, we are going to add 8 from the right-hand side of the equation, and we can add 8 to, or excuse me, add 8 from the left-hand side and add 8 to the right-hand side. Z drops down, -8 plus 8 is 0. We can just leave it blank. I like to put a little slash next to it. Equal sign, -10 plus 8 is equal to -2. Now if I model this final thing on the number line, I start at -10. Since I'm adding 8, that's increasing my value by 8 units. And I'll end up at a -2 at the end. Okay, so that is translating to an equation solving simple statements. Let's go ahead and do the same type of practice, but with a little longer word problems. Okay, so starting with this first question here, we have a submarine descends -48 feet in 4 equal intervals. Find the change in depth during each interval d by creating an equation and solving that equation. So if I first kind of draw this out to model it, the submarine is dropping -48 feet in total. We're then breaking that descent into 4 equal intervals. This is probably not drawn to scale, particularly at the end, but -48 feet downwards, and each of these intervals are the same amount of feet. Okay, so what we need to do is we're going to represent the d variable as representing basically each of these intervals. Okay, so there's a d variable, and another d variable, so there's 4 in total. So if I was to rewrite my equation, this would be basically 4d, and each of these then equals negative 48 feet in total here. Okay, so this is our equation. 4d, the d represents each interval, equals negative 48. Now solving this equation will then allow us to see what each different interval happens to be. So I will need to divide the left-hand side by 4 and the right-hand side by 4. And what we then get is d is equal to negative 12 here. Okay, so 4 clears away, that's 1, or the d, and then 48 divided by 4 is 12. Negative by a positive is a negative. So we get d equals negative 12. So each of these different intervals then basically descends negative 12, and maybe that stops for a bit, descends another negative 12, it stops, so on and so forth, down the chain. Okay, looking at question number 2 now, we have a bank account decreased by $72. So decreased by $72, that's a negative 72. After several equal withdrawals, so withdrawals of 12 each. So that also, this part also equals negative 12. Okay, so negative and a negative. Let W represent the number of withdrawals. Write and solve an equation to find W. So we're basically trying to determine, okay, how many withdrawals were actually made. Okay, so we know, just to kind of clarify what we know the account decreased by 72. So the total change is negative 72. That would be the, we'll say the right side of our equation. Now, each withdrawal changes the account by negative 12. The W variable then represents the number of withdrawals. So this then gives us the equation 12W equals negative 72. So our final step is to actually solve this equation. So we're going to solve by dividing negative 12 on the left-hand side and negative 12 on the right-hand side. This clears away the two initial variables. I'm just left with the W variable representing one withdrawal equals negative 72 divided by negative 12. So 72 divided by 12 is 6. A negative by a negative is a positive, so we're just left with positive 6, which makes sense. We're really looking for a positive number here, the number of withdrawals that are made. Okay, so our final answer is W equals 6. Okay, so that concludes our presentation on Chapter 3.5, solving equations using integers and the division property of equality. We looked at both modeling these types of problems. We looked at solving equations, and then finally looked at translating and solving equations, both with statements and word problems. So go ahead and get into the textbook chapter. You'll find the link in the description for the video. If you have any questions, feel free to reach out. Good luck and see you next time.